Hey everyone, welcome back to Cosmic Weekly. I'm your host Josh, and this week we're diving deep into three major stories that show just how dynamic and challenging space exploration really is right now. From a heart stopping last second launch abort to a groundbreaking discovery of a black hole in a famous star cluster, to the confirmation of a hidden giant planet in a well studied system, there's a lot to unpack. We'll take our time with each one so you get the full picture, the background, the science, why it matters, and what comes next. Let's get started. On the evening of July 16th, the eyes of the space world were fixed on Starbase in Texas. SpaceX was attempting Starship Flight 13, the second test flight of the upgraded version 3 vehicle. This wasn't just another test. It was carrying 20 real next generation Starlink V3 satellites for the first time, not mass simulators. The mission profile included a suborbital flight with stage separation, booster catch attempts, or controlled splashdown, satellite deployment, and testing of key upgrades from the previous flight. The countdown proceeded smoothly through propellant loading. At T-0, the 33 Raptor engines on the Super Heavy booster began their ignition sequence. Then, several engines failed to light properly. The vehicle's automated safety systems immediately triggered a full abort, shutting everything down cleanly on the pad. Elon Musk confirmed shortly after that two Raptors will need to be removed and replaced. The team is already working through the data, and the next attempt is likely early next week. Let's take a step back and understand why this matters so much. Starship is designed to be fully reusable, the most powerful rocket ever built, and is central to NASA's Artemis program for returning humans to the moon, as well as SpaceX's own plans for Starlink expansion and eventual Mars missions. Flight 12 in May has some issues. The booster didn't achieve a perfect controlled landing, and one engine on the upper stage failed during ascent. For Flight 13, engineers implemented hardware and software fixes focused on engine reliability, heat shield improvements, and better relight capabilities. The abort at ignition, while disappointing for the schedule, is actually a demonstration of robust safety engineering instead of risking an uneven thrust situation that could damage the vehicle or pad. The computers did exactly what they were supposed to do: stop the launch instantly. This iterative, fail fast, learn fast approach is what has made SpaceX so successful. With Falcon 9, we're still in the rapid development phase of Starship. Every test, even the aborts, bring valuable data that accelerates progress toward operational flights. In the coming days, expect more details on the exact engine issue and the timeline for the next attempt. If successful, Flight 13 could prove the way for the first full orbital Starship mission soon after. This program is moving incredibly fast, and we'll keep you updated every step of the way. Our second story takes us 18,000 light years away into the heart of Omega Centauri, the largest and most massive globular star cluster in the Milky Way galaxy. For decades, astronomers have suspected Omega Centauri should contain dozens or even hundreds of stellar mass black holes, the collapsed remnants of massive stars that lived and died billions of years ago. Yet direct evidence has been elusive because black holes don't emit light, and the cluster is incredibly dense with millions of stars. That changed this week. Using more than 20 years of archival data from the Hubble Space Telescope, combined with new supportive observations from the James Webb Space Telescope. Astronomers have confirmed the first stellar mass black hole in the cluster. They call it Omega Cat BH-2. The black hole is about 4.5 times the mass of our Sun and is orbiting with a visible companion star about 0.78 solar masses. The pair has the longest orbital period of any known black hole binary system. How did they find it? By meticulously tracking the subtle gravitational wobble of the companion star over many years. The invisible object's mass and behavior could only be explained by a black hole, too heavy to be a neutron star, but lighter than expected for a black hole in such an ancient metal-poor environment. Why is this discovery so significant? Omega Centauri is believed to be the stripped core of a dwarf galaxy that merged with the Milky Way long ago. Studying black holes here helps us understand how star clusters evolve, how black holes form and interact in crowded environments, and even provides clues about the growth of supermassive black holes at the center of galaxies. This find is just the tip of the iceberg. Astronomers now expect many more black holes in the cluster, and future observations with Webb and other telescopes would hunt for them. It beautifully demonstrates the power of combining long baseline Hubble data with Webb's infrared capabilities. This is a reminder that even in well-studied objects like Omega Centauri, there are still major surprises waiting to be discovered. For our final story, we travel 63 light years to the young star Beta Pictoris, one of the most famous and intensely studied planetary systems in our galactic neighborhood. Astronomers using the James Webb Space Telescope, along with ground-based instruments like the Very Large Telescope in Chile, have now confirmed a third giant planet in the system, Beta Pictoris d. The gas giant is roughly 2.4 times the mass of Jupiter and orbits much farther out, about 26 times the Earth-Sun distance, taking around 90 years to complete one orbit. It had been hiding for years, subtly shaping the inner edge of the system's bright debris disk. The planet was directly imaged, and its atmosphere shows clear signatures of carbon dioxide. Its temperature, colors, and chemistry are similar to other young directly imaged exoplanets, giving us a snapshot of what giant planets looked like in the early stages of system formation. Beta Pictoris was already known for two giant planets, B and C, and a massive debris disk, essentially a young solar system caught in the act of forming. Discovering the third planet helps explain the architecture of the disk and gives us a better understanding of how planets migrate and interact during the chaotic early years after a star is born. This makes Beta Pictoris only the second multi-planet system where we directly image 3 confirmed planets. Direct imaging is extremely difficult. It requires spotting a faint planet next to a very bright star. So this is a major technical achievement for Webb and ground-based adaptive optics. Systems like Beta Pictoris are time machines. They let us study processes that happened in our own solar system billions of years ago, when Jupiter and Saturn were forming and the planets were still settling into their stable orbits. As more data comes in, we'll learn even more about the chemistry and dynamics of this fascinating system. That's a wrap on episode 4 of Cosmic Weekly. We went deep on the Starship Abort and what it means for the future of reusable rockets, the groundbreaking black hole discovery in Omega Centauri, and the exciting confirmation of a third planet in the beta pictoris system. Which story resonated with you the most? Drop your thoughts in the comments, and I'll read every one, and it'll help shape future episodes. If you're enjoying the show, please like, subscribe, and hit the notification bell. We're building this channel together, one week at a time. Thanks for watching. Keep looking up, and I'll see you next week on Cosmic Weekly.